Hello everyone. Welcome to the distribution team demo on 27th July 2023. So this demo is also part of the series that we have been doing regarding distribution workflows. And this one will be focusing on how to enable a new feature based on the documentation and how to test it using our Helm charts. So this one is a follow-up to the previous video that Mitch did, which showed how to spin up a GitLab instance on GKE using our Helm charts. So we'll be continuing from that point where we have a functional GitLab instance, which runs GitLab, the latest version of GitLab using Helm charts. So the uh, demonstration uses a feature that is not enabled by default out of the box. So we'll be looking at enabling the metadata database for container registry. So this is an experimental feature that we added recently, and will be showing how to enable that in our instance and how to make sure that it is working. So let me share my screen. Okay, so this is our official documentation, the charts documentation for the container registry chart. And in there's a subsection called database, which describes how to enable the metadata database for container registry. So if we look at it, we can see it has a sample values.yaml entries that should go under the registry key. So yeah, it shows how to enable database, set a host, port, a user, how to specify password, the SSL connection, credentials and configuration, and all those things. In addition to passing these values to the deployment, because it is an experimental feature and not fully polished, it requires some manual actions. So the manual actions being one, we need to manually create a database for the registry to store metadata. Two, we need to create a user for the registry to access this database. So, and the credentials of this user will be stored as a Kubernetes secret. So the documentation also has instructions regarding that, how to create a Kubernetes secret with the password, how to fall into our Postgres shell to create a database, create a user, specify ownership of the database, and all those things. So we'll be going through these steps and showing how the metadata database is functioning at the end of the demo. So switching to my terminal. So this is similar to what we did in the previous video where we deployed a GitLab instance using GKE with our Helm charts. So on the bottom left corner, this is the configuration that I used, which is very similar to what was done in the previous video. And we can see in K9s, all the ports are running fine and without any issues. So the manual steps, if we look at the documentation, the manual steps start with creating a secret with the database password. So it uses the kube control create secret. This is a generic secret, not a dedicated one like a TLS certificate or anything. A secret name from literal, the key in the secret where the password will be stored, and a password string. So let's try doing that. So yeah, kube control, because we deployed it to the GitLab namespace, we'll be passing the namespace. The create secret generic. This is the name of the secret that I'm using from literal, and this is the key. I'm using password as the key. And the value for the password, I used a simple one called 2 minute secrets, but you have to obviously use a secure one if you are doing this in production. So yeah, let's confirm that it got created. If we look at okay, there is the GitLab registered database password. Let's try decoding it. And yeah, it has the password key and too many secrets as the password value, which matches what we did. The next one is login to your database instance. The command here is a two-part one. The inner one identifies the pod name of your PostgreSQL pod, and the outer one folds into the shell in that pod. So if we look at our pods, we can see that GitLab PostgreSQL 0 is the port name. So let's fall into that pod. Okay, we are inside the Postgres pod. Now we need a PSQL shell to create the database and create the user. Again, in the documentation, we have specified how to get a PSQL shell, which we copy. And here we have fallen into the PSQL shell. So let's create a database user. I am giving the username as a registry itself. Created the role. We need to set the password. The documentation specifies to fetch the password in case you forgot what you gave or in case you don't have it. But since we know what ours was, we can do it. So I am giving the same too many secrets as password. Now let's create the database and specify the user registry as the owner. So both the database name and the username is a registry. You can give whatever you want. So yeah, we created the database. Let's come out of both the PSQL shell and the pod. So yeah, we have completed all the manual steps required. Now we need to specify these configuration values according to our need. The documentation shows all the available configurations. For demo purposes, I am using a minimal version of that. So I added the following to my values.yaml file. The registry key database enable. Because this is demo, I am not using any SSL connection between the registry and the database or PostgreSQL. So I have disabled SSL mode. The user. So this is the database user that we created earlier with username registry and password. The password is in the secret that we created with the password key being what we specified password. So let's save that configuration file and we need to deploy the charts again. So this is the same command we used to install charts the first day. Because we use Helm upgrade -- install, it serves both purposes. If it is a fresh installation, it installs the chart. If it is an upgrade, it detects that and upgrades the deployment with the new configuration values. So let's try upgrading our Helm chart with our deployment with this new configuration. Now, this can be a bit time consuming depending on various factors like network connectivity or the load on the cluster and all those things. But hopefully in the pods that are running on the cluster, we should be seeing newer pods coming up related to the metadata database and the old ones being deleted. Helm is intelligent enough to detect if there are any changes to any other services. If there are none, those ports will be left as is, and only the registry related ones will be deleted and new ones deployed. So hopefully the two registry ports that we see in this cluster will get deleted and the new ones will be deployed. Now we wait. Okay, so we can see newer jobs coming up. One is an upgrade check, because this is technically an upgrade from a previous installation. We enforce certain upgrade paths. So we have a job confirming that user is upgrading from the supported minimum version to the current one. So we can see changes happening in the cluster. So the Helm update command itself has not exited successfully, so it is still going on. Okay, we can see new registry ports coming up. There's a registry migrations one. Let's check the logs on that one. We can see migrations happening on the metadata database. And we can see newer ports coming up without any issues. And the old ones, like once the newer ports are up and running and we satisfy the requirements of the registry ports, the older ones will get automatically terminated. Like we see here, the older one is getting terminated and the next one is spinning up. The other one is also terminated. So yeah, we have successfully deployed the registry changes. If we want to confirm, we can fall into the registry port and see that the configuration changes have gone in. Let's forward to a shell in the one of the registry ports. If we look at the configuration file at /etc/docker registry config.yaml, we can see that it has the database related configurations with the password. The PostgreSQL host is automatically detected from our running PostgreSQL port and the port. The user we specified, the password we specified, SSL mode is disabled. So everything looks right. let's come out of the board. Now to confirm that if it is working as we intended, let's try logging into our instance. For that, we need to find the password for initial root password, which we automatically created. Okay, so we are in the instance. Let's try creating a sample project. Okay, we have a new project created, and the container registry is empty, as we just created a new project. Let's try pushing an image to this registry. First, we need to log in, root, and the password for the root user. I am going to tag the Alpine latest image to this registry. So we can see the push going through. Okay, the image has been pushed. If we refresh the container registry page in UI, we should be able to see that. Okay, now to ensure that the metadata database actually works, let's check what the contents of the database that we created are. Let's fall into the PostgreSQL shell once more. And let's get a PSQL shell. But this time let's use the registry database and check what all tables are there. Okay, it has all these tables. Let's see if the tag we put ended up in this table. Okay, top level namespace ID1, repository ID1, there's a latest tag, which matches with our project. So the project has the ID1, so it is that project that the table is mentioning about. So yeah, the metadata database is working as expected, and the configuration change we created worked fine. There were no errors with migrations or registry ports to come up. So I'll stop sharing my screen now. Okay. Which for some reason is not working. But anyway, so yeah, the demo is essentially this: how you specify newer configuration to your values.yaml file, and how you apply those configurations to a running GitLab instance, so that you can test newer functionality and see it in action. So with that, the demonstration is complete. I'll see you everyone at the next demo. Bye.